Launch delays and scrubs are quite normal in spaceflight, and when the rocket in question is as large and complex as Starship, it's even more likely that we'll witness these kinds of holdups. But still, for those of us who had been glued to our screens, eagerly waiting to see this gigantic monster lift off once again, it was disappointing to hear the countdown stop so close to launch. And if you're feeling frustrated or wondering what exactly happened, you're not alone. In this video, we're going to break down everything that led to the delay, what went wrong, why SpaceX had to halt the countdown, and when we can expect the next launch attempt. Before we delve any deeper, make sure to subscribe to our channel for future updates on Starship, SpaceX's other groundbreaking achievements, and the future of space travel. Now, let's get into what really happened. The day started with a lot of excitement as SpaceX prepared for another big step in its Starship program. The launch was set for later in the evening, but even in the early hours, the team was already busy with final checks and preparations. Everything was in place, but there was still a long list of things to do before liftoff. About 5 hours before launch, engineers were focused on system checks, making sure every part of the rocket was functioning perfectly. This meant checking the structure, avionics, and propulsion systems. At the same time, the ground team was preparing the fuel system, ensuring the right amount of liquid methane and liquid oxygen were ready to be loaded into the rocket. These fuels needed to be kept at extremely low temperatures, so everything had to be handled with precision. 4 hours before launch, SpaceX reviewed all safety procedures and confirmed that the surrounding areas were clear. They also kept a close eye on the weather, making sure conditions were safe for liftoff. There were some clouds in the sky, but nothing that would cause delays. 3 hours before launch, the fueling process officially began. Liquid methane and liquid oxygen were slowly pumped into the tanks of both the booster and the upper stage of Starship. This was a critical phase, as the propellants had to be kept at the right temperatures to ensure a smooth burn during liftoff. 2 hours before launch, the engines were chilled down in preparation for ignition. This step helped prevent any sudden thermal shock when the engines fired up. Engineers also did a last-minute check of all systems to confirm that everything was still on track. There was no room for mistakes at this stage. Any small issue could cause a delay. An hour before launch, the launch director ran through a final go-no-go poll, checking with each team to confirm their readiness. One by one, teams reported that everything was good to go. With that confirmation, the countdown pressed forward. 40 minutes before launch, SpaceX started its live webcast, allowing people around the world to watch the event unfold in real time. As the countdown continued, final preparations were being made. The propellant tanks were pressurized, and the rocket switched to internal power, meaning it was now operating on its own systems. 20 minutes before launch, the launch pad was fully cleared of all non-essential personnel. The strongback, the large structure supporting the rocket, began to retract, giving Starship room to lift off. This was the last major step before the countdown entered its final phase. 10 minutes before launch, SpaceX confirmed that everything was proceeding as planned. The onboard computers took control of the countdown, running automatic checks and setting up the engines for ignition. At this point, all eyes were on the rocket, waiting for the final seconds to tick down. With just 2 minutes to go, the final go for launch was given. But just when everything seemed ready, at T-minus 40 seconds, the countdown suddenly stopped. The massive Starship rocket remained firmly on the launch pad, and SpaceX's mission control at Starbase went into full troubleshooting mode. Something had triggered an automatic hold, bringing the launch sequence to an abrupt pause. It was a tense moment, but not an unusual one in SpaceX's playbook. Unlike traditional launch sequences where issues appearing this late in the countdown often result in an automatic scrub, SpaceX's countdown architecture is designed to be more flexible. The T-minus 40-second mark is a particularly smart checkpoint. This built-in buffer gives engineers valuable time to analyze real-time data and determine whether the anomaly is a true threat or just a false alarm. Instead of wasting an entire launch window over a potential misreading, SpaceX can freeze the countdown, fix the issue, and continue if it's safe to do so. As engineers worked to diagnose the problem, initial reports suggested that the hold was related to the Super Heavy booster, the rocket's massive lower stage. SpaceX's live stream commentators speculated that a sensor had flagged something unexpected, though the exact nature of the problem remained unclear. Given the complexity of the system, there were a few likely culprits: an out-of-range pressure reading in the methane or oxygen tanks, a small leak in the plumbing, or even an issue with one of the 33 Raptor engines. From what was visible on the live feed, the booster looked fine. There were no obvious signs of venting, structural stress, or fuel leaks. However, even something as minor as a slightly misaligned valve could be enough to trigger the hold. SpaceX had faced similar situations in previous launches, where a last-second hold was caused by something as simple as a false pressure reading. The good news was that the team now had time to investigate rather than immediately scrubbing the launch. Meanwhile, Musk took to X, posting, "Holding at T-40s, investigating a potential issue with Booster 15, more updates soon." With the countdown paused, the mission control team reviewed telemetry data to pinpoint the exact issue. If it was something minor, like a software glitch or a faulty sensor, they could reset the system and restart the countdown within minutes. But if the problem was deeper, such as a fuel pressure anomaly or a mechanical issue in one of the engines, the launch would have to be postponed. Adding to the challenge, weather conditions weren't ideal. Observers near the launch site reported hazy skies and limited visibility, which SpaceX had already warned could be a factor. While Starship is built to handle tough weather, thick clouds can affect tracking cameras and guidance systems. SpaceX had estimated earlier that there was a 30% chance of a weather-related delay, so even if the booster issue was resolved, the team still had to keep an eye on conditions. As minutes passed and no restart was announced, it became clear that this wasn't just a minor hiccup. SpaceX confirmed that they needed more time to investigate, which meant the launch wouldn't happen right away. The company had two options: either attempt another launch later in the same window, if the problem was quickly fixable, or push the launch to another day if a deeper inspection was required. If the issue was simple, like a sensor needing recalibration, the engineers could potentially fix it within an hour and try again. However, if there was something wrong with the Raptor engines or the booster's fuel system, it would require draining the propellant and conducting a full inspection, likely delaying the launch by at least 24 to 48 hours. This was consistent with past Starship delays. During earlier test flights, similar last-second holds had resulted in a 1 to 2 day turnaround, while engineers worked through the data.